Now we'll review a technique you can use when you have a trinomial and your value for position C is a fairly large number that might be hard to do the math for. The technique we'll use here is called prime factorization. When we do prime factorization, we start with our number C, that's negative 216, and try dividing that number by small prime numbers. We're going to do this for as long as we can until we've broken up that 216 into prime numbers only. Let's try that now. We'll begin by saying negative 216, and then try dividing by the smallest prime number we can. The smallest prime number we can try is 2. We'll divide by 2, and if we take negative 216 divided by 2, we get negative 108. Now, negative 108 is an even number, and because that's an even number, we could continue dividing by 2. If we take negative 108 divided by 2, we will get negative 54. This is still an even number, so let's do this one more time. Negative 54 divided by 2 gives us negative 27. This is an odd number and cannot be divided by 2 any further. So now let's go to our next number on our list of prime numbers. Once we are finished with 2, our next number to try is 3. We'll take that negative 27 and divide by 3. This will give us negative 9. Of course, this is still an odd number, as expected. Let's take that negative 9, and we might notice negative 9 can be divided by 3 again. Negative 9 over 3 gives us negative 3, and that negative 3 is a prime number. Now that we have a prime number, we can stop. What we're going to do is now list that negative 216 as a series of prime numbers. Let's have another look at the numbers we divided by to get here. We divided by 2, and then we did it 3 times. So we have 3 2s in a row, and then we divided by 3, and divided by 3 again, and got negative 3 as our final result. So we can say 216 is the same as 2 times 2 times 2, because we had 3 2s, and then 3 times 3 times negative 3. This negative 216, written as this chain of small prime numbers, is what we call a prime factorization. We're going to use this prime factorization to figure out what numbers we could divide by in order to split that negative 216 into numbers we can use that could potentially add to make the b-value. So once again, let's review our basic factoring techniques. Anytime you have a trinomial like we have, we are looking for 2 numbers that could multiply to negative 216 and add to negative 15. To figure this out, we're going to divide that negative 216 by any combinations of numbers in the prime factorization chain that we can think of. However, we're going to try to narrow that down a little bit before we start, because as you can see, we have 6 numbers in our prime factorization chain and a lot of possible combinations. So as a rule of thumb, when you try this process, we want to make sure not to exceed the square root of 216. Let's make a note of what that is. If we have square root of 216, you will almost certainly need a calculator to find it. I'll bring mine up now. We'll say 216 and press square root, and we get 14.697 if we round it. And bearing in mind that we're only going to use whole numbers, this means in our experimentation we are not going to go above 14. Let's write down a few possibilities. We could use 2, since that's part of our chain. We could use 3. We could use 2 times 2, which is 4. since we have multiple 2's in our chain. We could use 2 times 3, that's 6. We could use 2 times 2 times 2, since we have 3 2's, a triple 2 in our chain, that would give us 8. We could use 3 times 3, that's 9. We could use 2 times 2 times 3, that's 12. We could even try 2 times 3 times 3, but if we multiply that, that'll give us 18. That's too high, and we don't want to use it because that exceeds the 14 we came up with earlier. Now, as always, even though we didn't write it, 1 is always a possibility for any number. So we have a total of 8 possibilities to try. Let's start by trying 2. We will take negative 216 divided by 2. This will give us negative 108. So now let's try the negative 108 we just got and the 2 we divided by and try adding those together. 2 minus 108 will give us negative 106. However, we're going for negative 15 and negative 106 will not match. Also notice it's very far off of negative 15. The fact that the answer we have is very far away from what we want means maybe we should skip forward in the list by quite a bit. For that reason, I'm going to skip a few steps forward and go toward 8. Let's take negative 216 divided by 8. When we do that, we will get negative 27. Then, let's try 8 minus 27 and see what we get. When we subtract, we will end up with negative 19. That's not a match for our negative 15, but it is close. So that means our answer will be close to 8, even though we know it's not 8. So let's go one step further and try 9. We'll take negative 216 divided by 9. When we take that division, we will get negative 24. When we take 9 minus 24, we will get negative 15, and that is a match. This means in order to factor, we will use positive 9 and negative 24 as our numbers. Now that we know positive 9 and negative 24 give us the negative 15, which is a match, we will now split that trinomial into 2 parentheses. The first parentheses will be x plus 9 for our first factor, and the other parentheses will be x minus 24. We write our parentheses, place x plus 9 in the first one, and x minus 24 in the second. Now that we have x's that are all first power, there's no way to factor any further. And so, this is the process we can use to factor a trinomial if the c term is extremely large.